In this video, I'm going to describe the theory and practice of infrared spectroscopy, also called IR spectroscopy. In general, spectroscopy involves the absorption or the emission of light by substances. Now, the observed pattern of light that's absorbed or emitted provides information on atomic and molecular structure. Our focus in the laboratory will be on absorption spectroscopy. We're going to be studying a number of different absorption spectroscopies. First, IR spectroscopy, then nuclear magnetic resonance spectroscopy, or NMR spectroscopy, then ultraviolet visible, or UV-vis spectroscopy. Absorption spectroscopy is classified according to the region of the light spectrum which is absorbed. We actually show here a number of different types of spectroscopy that see practice in the chemistry laboratory. We have, for example, radio wave spectroscopy. That kind of spectroscopy involves absorption of light in the radio wave region. There is a microwave spectroscopy, which correspondingly involves absorption of light in the microwave region. Infrared spectroscopy, of course, which is going to be our focus today. Ultraviolet visible spectroscopy involves absorption of light either in the UV or the visible range. There's also, just to point out further example, something called gamma ray spectroscopy. It is the most intense energy type of spectroscopy. It involves the absorption of gamma rays. Then there is another spectroscopy which technically doesn't involve the absorption of light, but rather the absorption of energy sufficient to break up molecules into ionic fragments. That's called mass spectroscopy.